Right, moving on. Question number 4 again. It's a medicine question, very similar and very simple and very informative. So compounds A and B both have the same molecular formula C5H10O. And they say both A and B give orange or red precipitate with 2,4 dinitrophenylhydrazine, which means this is the Brady's reagent. And you know, Brady's reagent normally react with aldehydes or ketones. So most probably this compound A and B, either aldehyde or ketone, or 2 aldehydes or 2 ketones, we don't know. When A and B are reacted separately with sodium borohydride in methanol, so it should give A would give C and B would give D. Okay, so this is a reduction. Okay, this is a reduction. Why? You add sodium borohydride. When C is heated with Al2O3, so you are going to heat this with Al2O3, which is a dehydration now. Okay, 2 alkenes are forming, E and F. E and F are react separately with conc H2SO4 again now, and the products obtained hydrolyzed. Now again hydration. So it is like reacting with diluted H2SO4 because you add conc then diluted. So to allow to hydrolyze. So this is like again hydration. Okay. So E and F reacted to form E gives G, E gives G, and F gives H. Okay, G gives turbidity immediately with Lucas, H gives turbidity with the, but not immediately, which gives the idea that G is a tertiary alcohol. Okay, this is a tertiary alcohol, and H is a secondary alcohol. Okay, so these are the informations that we can take from this one. Give me a second again. Sorry for that. So they're asking draw the structures of G and H. So automatically you should understand here E and F are alkenes that has the same molecular formula C5H10. Okay, so when you hydrolyze this one, it would form C5. Then basically what is happened, water molecule is added, right? So C5H12O. So what is basically going to happen is it will form 2 alcohols. One is a tertiary alcohol and the other one is secondary alcohol. Okay, so based on that, based on the number of carbon, you can automatically try to draw the tertiary alcohol and a secondary alcohol here. That is what they are asking, draw the structures of G and H. But before that, we will elaborate this question a little bit more. So compound, these 2 compounds will have this formula. So first we will try to draw the aldehydes and the ketones that we can obtain from this formula. That is what I have drawn here. So here there are 1, 2, 3, 4, 5 carbons, and 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 1 is 10 hydrogens. So this is the structure with 1 oxygen. So the basic aldehyde that I can draw is the linear chain, where you have 4 alkyl groups in the linear chain. Then I can attach this alkyl group from this place. That is what I have drawn here. And I can manipulate this entire chain to form the tertiary carbon. Okay, this is a secondary carbon now. This is a tertiary carbon with 3 alkyl. This is a secondary carbon with 2 alkyl groups. Okay, so these 2 are 2 basic structures. The other thing is when you consider about the ketone, again, I can draw 3 different compounds. Okay, this one would be 1 ketone with 1 CH3 group on one side, the other 3 in the opposite side. So I can take this 1 CH3 to this side and draw this one. Or I can keep this CH3, CH2, CH2 group here in this side and manipulate its structure by branching here in this position. So I will have this one. Okay. Then when A and B are reacted, so what I am trying to tell you is get something from this question. Okay. So in the exam also, it is better that you can quickly draw these structures, because these are very simple things, not hard things. Okay. You should be able to quickly draw these structures. Okay, otherwise there is a problem with you, I would say. So try to draw these structures very quickly, you think. Okay. Then you can elaborate more what would happen in the next steps and what would happen in the next steps, following steps, like that. Okay. Then let's move forward a little bit. So you add sodium borohydride and methanol and you reduce this. So this would give C and D, but we don't know still what is A and B here. But if you hydrolyze this one here, this terminal CHO will be now CH2OH. Okay, attached to this CH2 chain. And here also this should be like CH2OH. Okay, and there will be this hydrogen, and this is CH3, and this is a CH2CH3 group. Okay, this one also would be CH2OH. Now carbon and 3 carbons more here. Okay, so this is the way. These three, now this one would have OH here. Okay, and 2 carbons here and 2 carbons here, and there will be 1 hydrogen here. This one again, OH, CH3, hydrogen, CH3, CH3. This one again would have CO, CH3, CH2, CH2, and CH3. Here this is converted to OH. Eraser. Go. OH and hydrogen. Okay, so this is 3 structures that you can draw here. And what do you think about here? Is there a tertiary alcohol here? Sorry again. That is formed. So initially no, right? So these are the compounds that you can get when you add what do you call the sodium borohydride. Then it says you can heat it again with Al2O3. So when you heat this C, it would form E, and D would form F. So again, when you heat, what is going to happen? Here, this OH and one of the hydrogens will go. Here, this OH and this hydrogen would go. Okay, and here this OH and no hydrogen is there here to go. So totally, I'm going to neglect these structures. And here, this OH and one of the hydrogens here would go. And here, this OH, here don't forget, here there's a CH3 group. So this OH is in this carbon. So either one of this hydrogen or this hydrogen can go. Now here in this one, this OH or either one of this hydrogen or one of this hydrogen can go. This OH, either one of hydrogen, this hydrogen is this. So this is what normally going to happen. Okay. And in the next step, so you know all these compounds would form alkenes now. And in the next step, again, you're going to add water molecule. Okay, hydration. So when you do the hydration again, G and H are formed, which are now alcohols. So when you hydrate, it should form a tertiary alcohol and a secondary alcohol. So that is the point here, because G gives instant turbidity and H gives a little bit in low in time. Okay, not very quickly after a certain time. Now you need to find out of these remaining structures, we have like 5 structures, right? Which structures could form these tertiary and secondary alcohols? So that is the normal way, right? So here when you hydrate this one, so this should be alkene with CH double bond CH2, right? With the linear chain. So when you hydrate this one, it will be CH3 here, and the rest of the chain is here, OH is here, and H is here. Okay. So if I draw this one with a separate, let's say separate color, the brown color. So this would give like OH, CH3, hydrogen, and a linear chain. 1, 2, 3, 4, 5. Okay, because hydrogen is added to the place where you have maximum hydrogen according to the Markovnikov rule. This one, when you rehydrate first, so this OH and H is removed. Then when you hydrate, it will form the alkene with a double bond here. And then when you hydrate again, this could form the so when you rehydrate, this hydrogen is not there basically. Again here what it forms, here there will be a OH, and here there will be CH CH3 here, CH3 here, and CH3 here. Okay, so I'm already seeing a secondary alcohol and a tertiary alcohol from these 2 structures. And here when you come to this section, so initially there will be a double bond here like this, CH, and double bond here, CH2, and the rest of the chain, R group, with CH2 and CH2 and CH3. Okay. So when I hydrate again, so again there will be CH3 here. Okay. One CH3 here, and there will be OH here to form the single bond. If the hydrogen eliminate from this position, and if the hydrogen eliminate from this position, then again what is going to happen? Okay, so this is from this position, because initially CH2 is formed, then hydrogen is added to this, so it is added to this. And from this position, so again what is going to happen? Here there are CH2, there is one other hydrogen, there is another hydrogen. So again, there will be OH added to this place, and CH3 here, and hydrogen is here, and Now in this place again there is one hydrogen, although there is a double bond, there is one hydrogen. So according to Markovnikov rule, there will be this CH2, CH3 and CH3. So this structure is very similar to this one if this comes from this position. So this cannot be because those two are different compounds. Okay, you cannot have E and no, C and G in the same way. Okay, so this is more or less not likely to be. Right, so here in the similar way you can check, here also in the similar way you can check. So if you dehydrate again, so this would form a double bond either in this side or this side, and when you do the rehydration again, so again it will form the same compound here. Okay, CH2 CH2, there's a hydrogen here. Okay, give me a second. So when the dehydration happens from this side, it is the same because this is a symmetric molecule. So again, you will have like here now it is CH, there will be no OH. Then when you dehydrate again, so Markovnikov rule, hydrogen is here, OH is here. Okay. So it is also like same compound, right? Initially it was like this, now also it was like this. It is like this. So it's not good. When you come to these structures, okay, so you have OH and CH3 in both sides. What is missing here? OH is there, CH3 is there, hydrogen, carbon is there, 2 CH3 and 1 hydrogen should be here. So when you dehydrate initially, this OH and this one of the hydrogens can go like this to form CH2, and there is this hydrogen and 2 CH3. Okay, so write down these things. Okay, this is from this hydrogen, from this hydrogen it would form, there is a CH3 compound here, and this hydrogen will be there, this OH and this hydrogen will be gone. So this is carbon carbon double bond, and there will be 2 CH3 groups like this. Okay, then you are going to hydrate this. So when you hydrate this, because this is the final step, conc H2SO4 and hydrolyze. So again, when you hydrolyze this one, what is going to happen? Basically here it will be CH3 single bond here. Yeah, initially there is no hydrogen initially. No, it is OH. Right, so this is the structure again that we are going to get. So you dehydrate CH2, and there was this hydrogen that is going to eliminate. So this OH and this hydrogen is gone, and yeah, there is a small mistake. Initially, when you do the dehydration, there will be CH2 here. This OH is gone, so there is hydrogen and CH3. And when you hydrolyze, there will be this OH and CH3. This is the structure that is going to come. Okay. I am correct. CH3, OH, CH, C here. Yeah, again mistake. Because it should be 5 carbons. 1, 2, 3. Which one? Which is this carbon? And 2 CH3 groups opposite. Okay, and hydrogens. So again, you see this structure is very similar to this one. So again, it could be a problem. Okay. So basically, if you think about the structures that is remaining, I will take a different color. This one. Okay. So the possible structures that remain here, it could be this one. It could be this one. And at the same time, it could be this one also. All others are not coming, right? We'll check this one for the moment. So if you take the hydration, there will be CH2 here. And this OH is going to go. And from this place, CH3 is there. When you add the hydration, then yeah, so basically when you add the hydration for this particular molecule, so I will draw this one again here. This is OH, this is CH3, this is the carbons. Okay, CH3, CH3, there is hydrogen. So when you dehydrate, so from this position, I have already dehydrated and drawn. This is not coming from this position. So there will be a double bond here. So this hydrogen and oxygen is not there initially. Okay, and then you again hydrate it. So when you hydrate it, there is a hydrogen here. So again, there will be OH here, and this hydrogen is going to form. So this is structure, and this structure is again same. So again, this is problematic. Okay. Right. So we have actually found the two compounds that is going to form this. Okay. Sorry again. This is the tertiary structure, and this is the secondary structure that is going to be present in our structure. So basically, the tertiary structure is now, yeah, there should be another carbon here. 1, 2, 3, 4, 5. So basically, the tertiary structure should be this one. Okay. CH2, CH3, and OH. This is the one. And the secondary structure could be this one, CH3, OH, this one, and you can draw this structure. Okay. Draw the structure of ACEF. So based on this explanation, you can find all the structures very easily, right? So try to go through this very slowly and try to understand what is the concept behind, and try to understand the difference between these two. Okay. That is very easy to understand. So you can, so you have the structures G and H here, CH3, CH3, and H. So you can now come backwards to draw ACEF, or from G you can get E, and from H you can get F here, the two alkenes here. Okay, it should be E here and F here. Okay, then you can again go back to A from here. Okay, so basically you have A, C, and F structures. So what is D here? That's the next part, right? So they say when heated with Al2O3, D gives alkene I, and I is reacted with conc H2SO4 and the product obtained hydrolyzed. G is obtained again. So G is obtained again. So based on that, you have to find what could be this D as well. Okay, so the easy way to draw that is you just need to think about the rest of the compounds here that we have drawn, and then you need to check whether you react with this Al2O3, which means you dehydrate it and you again hydrate it, you will obtain the same compound G. So what would give the same compound G when one of these compounds get dehydrated and then hydrated again? Okay, so think about that a little bit. Which one would get the same structure when you dehydrate it and then you rehydrate it? That's the point. That's a very simple question that I ask. Okay, you have this structure, this structure, this structure. So when you answer for these particular things, you see only two structures that we have used out of these things. Okay, so one is this one, where you have, one is this structure. Okay, the other one is this tertiary alcohol that we obtain here, this is structure. And when you dehydrate it and rehydrate it, so remaining structures are this one, this, this. From this one is obtained, the other one is remaining here. So you can check based on that what structure would come. Okay, I'm not going to dive deep into this because we have already discussed these type of questions more and more. So you just need to consider what structure can be taken there in order to determine the structure. Basically, if you consider about the remaining structures, so this could be one of the structures that can be taken here. So you have the aldehyde CH3 CHO. So because this aldehyde pair that is branched here could be used again also. Yeah, this one also might come because we don't know, because it says it forms a tertiary alcohol. So if you guess this is the tertiary alcohol D, I mean here it is G, so the aldehyde should be this one. Okay, but if you find the ketone from this one that forms this tertiary alcohol, that ketone which gives the structure either A or no, it's A, the structure of A should be either from here, a ketone. So basically, if you think about the structure here, when you get the structure here, you will automatically see it is a ketone, very straightforward, because you are getting that from G when you know the structure of G. Okay, so that's the idea. You know the structure of G means you know what is the ketone here. So it should be this one, right? The basic idea is this, or here this. So this could be A after the hydrolysis. Okay. Then if this is A, surely if that is coming from a ketone, the other one could come from an aldehyde. So it is from this one to give the tertiary same type of G structure. Okay. So to answer this question, actually you don't have to go through all these structures, but I am trying to explain you there are many things that you can take from here. Okay, because immediately if they're given here this is a tertiary and secondary, based on the formula you can automatically draw two structures for the tertiary and secondary alcohols, and you can go back from there to this backward direction. That is easy. Okay, but at the same time you need to understand this question is informative, so you need to get all the things by going slowly and get the information. That's my idea. Okay, so the rest of the things are very Okay, very easy. Okay. So based on this, if my aldehyde is this one, you can draw here in this box this aldehyde. Basically, it would be CH3, CH, and this aldehyde, and this one here. It is, I think, another. Yeah, aldehyde is there, and here it will be a hydrogen based on this structure, and CH3 and CH2, CH3, this one. So you know this, if this is B, then it would be D gives the hydrated product, like the reduced form. And when the reduced form is there, again you need to hydrolyze, dehydrate to get the tertiary product. So basically what is happening here is there will be CH3, CH2, this would be CH3. If I draw CH3 here, so this would be CH2OH. You know, hydrate, or when you reduce with sodium borohydrate. So then you dehydrate this again. So here it will form CH2. This is CH2 probably. There is hydrogen here, don't forget. So this would dehydrate. And there will be a double bond here now. CH2. Okay. Then when you do the hydrolysis again here, there will be this CH3 group forming here, and there will be this CH3 and the rest of the part, and there can be a tertiary alcohol that can be formed. Okay, give me a second. Then describe a test reaction to distinguish between A and B. So now you understand A is a ketone, B is a aldehyde. So it is very straightforward now. So from this part also, if you think a little bit more, you can automatically guess one should be an aldehyde, the other one should be a ketone, right? So you can either write down the tolerance test or failing solution test and distinguish the observation as well. Okay, so another part here. So give the structures of JKLM in the following reaction sequence. So you have a benzene. So this is normal reaction for benzene reactions are electrophilic substitution reactions. So this is SE reaction. This is a SC reaction. So you will have the structure here, the CO CH3 group. This is very common. And when you add this Grignard reagent, so it will attack here. So this is a nucleophilic addition. So AN reaction. And when you hydrolyzed, it will form nicely the hydrolyzed product. So there will be OH here. And not OH, CO here. And then OH here. And triple bonded carbon here. And CH3 here. This is a carbon. And in this side, so CH3CO. So this will be a CH3 group. And then palladium quinoline. So this reduce this double bond to a triple bond to a double bond. So that is the normal way that you can write down. But remember, nothing happens to the OH. So it could be this one. Carbon, which will be there in the same way. There is this CH3 group, nothing happens. But here the triple bond will become a double bond. Okay. So you have to write down the structure of J, K, and L. So these are the structures. And there is another reaction given, reaction 3. So H2SO4 is added. So basically what is happening, this pi bond attacks this one hydrogen and this bond breaks down. So basically this will form CH3, CH3 hydrogen, CH3, and here there will be OSO3. And when you hydrolyze this, this will form OH. That is what normally happens, right? Selecting from the list given below, write the type of reaction that takes in reactions 1, 2, and 3. Yeah, so one is electrophilic substitution. This is nucleophilic addition, where you add this part. And here, this is again starting from the pi bond and H plus. So this is electrophilic. But what is this? Electrophilic addition, right? It's an electrophilic addition. So these are very simple things. Using the knowledge of the mechanism of the reaction between alky and HBr, give the mechanism of reaction 3. So reaction 3 is the reaction that gives the product M. Sorry. So that is what I have drawn here very simply. So don't draw that like this. So you can draw like this, show separately one hydrogen from this structure. That is what normally good. So you can show SO3 OH separately, SO3H. So normally you can show this double bond CH2 here and the rest of the things. So this should attack here and this bond form towards this oxygen direction. And then it will form this cation here, carbocation, positive charge, 2 carbons, the rest carbons. And then this OCH3 minus, OCH3 minus, not OCH3 minus, OSO3H would attack this and form this compound. That's the idea. Okay. Sorry again. Okay, so this question is not hard. This question is a little bit straightforward. The only thing is I spent some time to give you some idea about this, how you can approach. And moreover, when you have given a formula, you should first try to write down all the structures, possible structures, then decide based on them. That would be very, very easy. But if you are like not an expert in drawing the structures, so try to go through the reactions first, and then try to write down 1 or 2 structures, and then try to answer based on that. Okay.